The Physics of Finance. An undergraduate physics project presented by Molly, Mofta, Paolo, Abby, and Shay. In the aftermath of the 2008 economic crash, investors were looking for explanations, and many people's blame fell on the increasing amount of complex financial tools, and on the people that had created them, namely physicists. Contradictingly, some physicists utilized their methods so that they still produced returns in the crisis, most notably Jim Simons, a physicist from the University of California, who founded the company Renaissance Technology and the hedge fund Medallion. A hedge fund is a limited partnership of private investors whose money is managed by professionals to earn above-average returns. During the economic downfall starting in 2007, on average hedge funds returned about 10% that year, whereas Simon's Medallion Fund returned 73.7%. Untraditionally, one-third of his employees are composed of people with PhDs in physics and maths-related subjects, suggesting that the unconventional applications of physics can offer exceptional results in finance. Although not entirely obvious, the link between physics and finance is intrinsic. Throughout history there has been notable examples of applying ideas developed in physics to seemingly unrelated topics in finance. However, as Newton noted after losing his hat in a market collapse, I can calculate the movement of stars, but not the madness of men. Financial markets required deep analysis, and this relationship is not without scrutiny. This mini-video series offers an introduction to key applications of physics in finance, and is aimed at the undergraduate level, with the aim to convince viewers of the exceptional results available from the combination of the two fields, and the convincing argument as to why many physicists seek a career in finance. Applications of physics in finance have a broad scope. In this series, we will introduce a short history, Brownian motion, the Black-Scholes equation, random walk modeling, option pricing, and the future of financial physics. Key mathematical and financial concepts will also be explained. We approach this project in a quantitative manner, with the intention to highlight the relevant physics, but we also offer qualitative explanations and an examination of the relationship. Briefly, the key goals of banks, insurance companies and finance houses are to maximize gains by increasing the value of their investments and minimizing risk. With this in mind, physicists and economists have sought novel ways in which to predict market movements and stock prices in order to make money for themselves or a company. The physics way of thinking privileges evidence and accuracy when making models. In this sense, it can offer a new approach to finance. This relationship has been described as economics being fertilized by physics. The physics way of thinking is constantly updating your best models and theories in light of new evidence. In this sense, as James Weatherall concludes in his book, The Physics of Finance, it is, in fact, the people who used physics models without thinking like physicists which were the actual problem in the 2008 market crash.